group number 4, the first question was to define inheritance in Python. Inheritance, it is a fundamental concept in object-oriented program that allow you to create a new class based on an existing parent class. Here there is the concept element involved in inheritance. There is the parent class, subclass, and here there is the benefit of inheritance: code reusability, maintainability, extensibility, and modeling relationship. The B is to show the syntax of inheritance in Python. Here there is the syntax: class and subclass name, parentheses, the parent class name. C is to define the types of inheritance. The first is the single inheritance. It is where the child class inherits from the single parent class. It is the most basic and straightforward type of inheritance. Here we take an example and we run it in the PyCharm. After running, here there is an output. The second, it is the multi-level inheritance. A child class inherits from another child class which inherits from the parent class. Here there is an example. After running into the PyCharm, we saw the output. It is this. See, it is the hierarchical inheritance. The multiple child class inherit from the single parent class, creating the hierarchical. Here there is an example. After running, there is an output here. And there is the multi-level inheritance. A subclass inherits from another subclass, which then inherits from a basic class. Here there is the syntax of multi-level, and after the syntax we take an example, and after running that example we saw the output. It is like this. And D, it is to determine the Python inheritance perfection. It is the powerful tool in Python inheritance that allows you to access and call a function. The purpose to provide convenience. It avoids the naming conflict. Here there is the syntax. And the second question, it is to define the Python override method. It is the ability of subclass to define the method with the same name, parameters, and return type. And the benefit of override method, it is the flexibility, code reusability, and polymorphism. Here there is the syntax, and after syntax we take an example, and you see the output is this. Let me call my colleague and continue with the third question.
Here the third question is about polymorphism. First, polymorphism refers to the method, function, operators with the same name that can be executed on many objects or classes. An example of Python function can be used on different objects is like len function. String len return the number of characters, and we declare the variable called x, and we print and we assign this hero word and we print len x. Polymorphism in Python refers to the ability of objects to exhibit different behavior in response to the same method call. Here there is two main ways polymorphism can be achieved in Python. First is duck typing. Refers to the duck typing, which means that objects are considered compatible if they have necessary method or attribute. Example, we define greet and we put the parameter animal, and we make a subclass called dog, and after running we get the output that dog, wolf, and cat, meow. Polymorphism function with function and object. Define generic function. Create function that takes object and argument as an argument. Inside function, we call method with specific name on object. We define spec. This function demonstrates polymorphism that accepting any object will make sound method and calling it to produce the sound, and animal makes sound. This example, the speak function is designed to work with many objects that has makes. Second is create object with required method. Define class for different object, example dog and cat. Make sure each class has the make sound method defined with specific behavior. And here the class dog and its class with the sound. And here if we print we make the cat mew and the dog wolf. Polymorphic usage. Create instance of different object classes. Pass each object as argument to the generic function. Here we are going to create animal object. My dog equal my dog, my cat equal my cat. Polymorphic usage speak function works with both dog and cat object. Speak in parentheses put my dog, output will be wolf, dog wolf, and speak my cat, output will be cat mew. And here we are going to encapsulation. I will invite my colleague to continue.
Let's continue with question 4. Encapsulation in Python refers to the concept of binding data, attributes, and method functions that operate on that data within a single unit called a class. This restricts direct access to the data, promoting data protection and improving code organization. Key characteristics: data hiding. Unlike some other object-oriented programming languages, Python doesn't enforce strict data hiding through access specifiers like public, private, or protected. However, it achieves a similar effect through naming conversions. Public members, attribute and method prefixed with neither underscores or double underscores are considered public and can be accessed from anywhere within a program, inside or outside the class. Private members, attributes prefixed with a single underscore are considered private by conversion and are meant to be accessed only with the class or its subclasses. While technically accessible from outside, they generally not recommended to modify them directly. Methods are accessory and routers. Encapsulation encourages using methods to access and modify the internal data of a class. These methods can perform validation, data processing, or other operations before exposing or updating the data. Benefits of encapsulation. Data protection. By restricting direct access to attribute, encapsulation helps to prevent accidental modification of data that could lead to program errors or unexpected behavior. Another is improved code organization. Grouping data and methods within a class promotes modularity and makes code area to understand and maintain. Flexibility. You can control the access of data by modifying the naming conversion, interbreak adding or removing underscores as needed. This is an example of encapsulation, as you see. Number 5, set and getter method. Set and getter method in Python. While Python doesn't have built-in access modifiers, private, public, protected like some other object-oriented languages, set and getter method provide a way to control attributes access and potential add validation logic. Getter methods. These are methods used to retrieve the value of an attribute within a class. Another, they typically have a name that starts with get followed by the attribute's name, e.g. get name and get age. Another, their primary function is to return the current value of the attribute. Setter methods. These are methods used to modify the value of an attribute within a class. They typically have name that starts with set followed by attribute's name, set name, and set age. Their primary function is to take argument the new value of the assigned and update the attribute's value, potentially performing validation or other operation before assignment. As you see, this is an example of data and getter. The see we have finished as group 4. Thanks.